In web development, there are certain things we just accept as fundamental truths. And one of the biggest is the build step, that whole dance of bundling, compiling, and packaging our code before we can ship it. But what if that wasn't the only way? What if we could challenge that core assumption? Today, we're diving into a technology that does exactly that. So welcome to the runtime revolution. I think every successful engineering team hits this wall eventually. You're hiring more people, you're shipping features like crazy, your user base is growing. I mean, by every metric, you are winning. And yet, the day-to-day work of developing, building, and deploying that code starts to feel like you're wading through concrete. Your own success is what's slowing you down. It's a crazy paradox. So where is all this friction coming from? Well, the root cause is usually an architecture that we all start with, and for very good reason, the monolith. It works beautifully at the beginning, but as we're about to see, the price of success is that your monolith can become your single biggest bottleneck. And this slide just lays it out so perfectly. We all start on the left, right, with that clean, simple monolith. One team, one code base, total clarity. But then you succeed. You add a feature, you add another team, and each one adds another thread to the system. Before you know it, you end up with that tangled web on the right, where it's almost impossible to see where one team's code ends and another's begins. And that tangled mess, well, it leads to these 5 very real pains. Your development speed just grinds to a halt. A tiny bug in one small feature can bring down the entire application because there's absolutely no isolation. Your teams lose their autonomy. They're constantly blocked, waiting on each other. Every single deployment becomes this huge, high-stakes event. And even simple maintenance starts to feel like you're diffusing a bomb. So the logical next step, the answer from the industry, was micro frontends, right? Let's just break up the UI the same way we broke up the backend. But this just traded one problem for another, a new hidden problem. You got rid of the monolith, but now you have this complex web of dependencies. If a tiny shared component, like a button, needs an update, now 5 different teams have to coordinate, rebuild, and redeploy their apps. That right there, that's the coordination tax. Okay, so this is where things get really interesting. To solve that coordination tax, you can't just change what you're building. You have to fundamentally change how you build it. And that brings us to the runtime revolution. This slide really illustrates the massive shift in thinking. On the left, you've got the old way, build time coupling. A bug in a shared library means every app that uses it is now chained to that bug. A fix requires every single team to rebuild and redeploy. But look at the right side. With runtime resolution, you break those chains. You publish the fix just once, and every app automatically grabs the new version the next time it loads. It's a total game changer. And the technology that makes this possible? It's called NUZ. It's an open-source runtime package manager for the web. Think about it. We all use build time package managers like NPM or Yarn, right? They work in our terminal when we're developing. NUZ takes that same idea, but it applies it live in the user's browser while the application is already running. And this quote from the next documentation, man, it just nails it. A require statement in Node.js goes and pulls code from your local Node modules folder, right? Next basically does the same thing, but instead of grabbing a file from your hard drive, it fetches that module over the network, live, at runtime. Okay, so you're probably wondering, how does this magic actually work? Well, it's not really magic. The whole news ecosystem boils down to 3 core concepts. First up, you have packages. Just think of these as your features, all nicely self-contained and versioned. Could be a button, could be a whole search page. Then there's the registry. This is the brain of the operation, the single source of truth that knows about every single version of every single package. And finally, the most powerful piece of the puzzle, composers. This is the secret sauce. The compose concept is the real engine here. It's like a package.json for your live application, but instead of being a static file in your code, it's a dynamic blueprint that lives up on the registry. So if you want to update a component that's used by 10 different apps, you don't open 10 pull requests. You just change one line in the composer file, and boom, every app instantly knows to fetch the new version. This is what enables instant updates and, just as importantly, instant rollbacks. All right, the theory is cool, but what does this actually mean in the real world? What's the impact? Let's look at some numbers from a big e-commerce platform that went all in on this. So these metrics come from Sendo, a huge e-commerce site that adopted a NUZ-based system. The result? A 12 times improvement in deployment time. What used to be a 36-minute, high-stress, everybody hold your breath event became a routine 3-minute publish.
I mean, that doesn't just change your team's velocity, it changes the entire culture.
And for all you developers watching, this one is huge. A 20 times improvement in local build times. Think about that. When you're not trying to rebuild the entire universe every single time you change one line of code, you can just focus on your work. It's a massive boost for productivity and, let's be real, for developer happiness. This chart just says it all, doesn't it? That 20-minute wait, that was a context switch. That was time to go get coffee, check your email, and completely lose your train of thought. Cutting that down to 1 minute keeps you in the zone, in a state of flow. This isn't just a 20x speed improvement. It's a fundamental improvement to the creative process of writing code. Now, this all sounds incredible, right? Almost too good to be true. And you know what they say in engineering? There is no such thing as a free lunch. Every big architectural decision is a trade-off. So let's get real about the other side of this coin. So, what's the catch? Because there's always a catch, right? When you adopt a new paradigm like this, you're giving some things up in order to gain others. Okay, let's break it down. On the benefit side, it's amazing. You get incredible team independence, instant updates, crazy fast builds. But the trade-offs are real and you have to take them seriously. You're adding a new critical dependency on the network. If your NUS registry goes down, your app might not load. You now have a new piece of core infrastructure you have to run and maintain. And debugging gets way more complex. You're no longer just debugging code. You're debugging why a specific version of a module failed to load for a user in a specific part of the world. That's a whole new class of problem. So that brings us to the million-dollar question. Given those very real trade-offs, when does an architecture like this actually make sense for your team or your company? Because, to be clear, this is definitely not for everyone. This whole runtime approach really starts to shine in a few specific scenarios. We're talking large organizations with, say, 5 or more front-end teams, where that coordination tax is already a daily, crippling pain. Platforms that need to ship updates constantly, like e-commerce or SaaS apps. It is an absolute game changer for a centralized design system that serves dozens of different ops. And it's a perfect fit for those complex super app architectures. Basically, if your build times and coordination overhead are already on an extreme level, the benefits here can start to seriously outweigh the operational costs. So I want to leave you with this one final thought. For our entire careers, most of us have been taught that an update and a deployment are basically the same thing. But a runtime architecture forces you to ask a really powerful question. What if your next update wasn't a deployment at all? What if shipping a critical bug fix or even launching a brand new feature was as simple as changing a single line in a config file? How would that fundamentally change the way you and your team build software?